In this lesson, we're going to look at surveys, observational studies, and experiments, and then we're going to also take a look at different sampling methods. So a survey is a questionnaire used to measure the characteristics and/or attitudes of people. So most of us know a survey. We've been given those time and time again by teachers, by stores where we shop, things like that. They give out lots of surveys these days. An observational study is different. That's when your individuals are observed and outcomes are measured, but no attempt is made to affect the outcome. And an experiment is different from those two because a treatment is imposed prior to observation. So the treatment can be anything that might affect the outcome. Let's look at some examples to help clear this up. So example A says a researcher gathered a group of people and asked them whether or not they took vitamin supplements. The researcher then compared the health of those who took vitamins and those who did not. So this could be an observational study because they did not impose any treatments, but they are observing whether or not they already took the vitamin supplements, and then they're comparing the health of those who took them with those who did not. B says a researcher gathered a group of people and divided them into two groups. One group got daily vitamin supplements and the other did not. After 1 year, the researcher compared the health of the two groups. So this is what we call an experiment because one group was asked to change their behavior and take the daily vitamin supplements. C says a random sample of 30 digital cameras is selected and divided into two groups. One group is given a brand name battery, while the other is given a generic battery. Pictures are taken under the identical conditions and the battery life of the two groups is compared. So this is again an experiment because the conditions were altered. One group was given a certain type of battery and the other group was given a different type. So that is still considered a treatment. Treatment does not have to mean medicine. It can mean all sorts of things. But if they're changing what one group does, then that's an experiment. And they can certainly change what more than one group does. But as long as they impose any sort of treatment, we have to call it an experiment. So D says using SAT scores to predict a student's college success has created some controversy. A study was conducted to examine the SAT and college GPA information of 105 students who graduated from a state university with a BS in computer science. So they're just examining the SAT and college GPA information of 105 students. Like they're looking at them, but they're not asking them any questions and they're not giving them any sort of treatment. So this is an observational study. E says, how much television is too much for children? Parents answered a questionnaire about their children's age, characteristic behavior, and television viewing habits. So this is a survey. So those are just some examples. That helps you get started of what's an observational study, experiment, or survey. Let's look at sampling methods for a few minutes. So one of the main purposes of statistics is to be able to find information about a small part of the population and then apply what we learned to the entire group, like we talked about in the last lesson. This is called sampling, and how a sample is gathered will make a big difference on whether the information you gather is accurate or not. The goal of sampling is to produce a representative sample, one that has the essential characteristics of the population that is being studied and is free of any type of bias. How do you keep your sample from becoming biased? The best way is to use some sort of random process to obtain it. There are several types of sampling methods we can use. So sampling methods, probability samples, each member of the population has a known probability of being selected. So like each member of the population should always have an equal chance of being chosen. So a simple random sample is when individuals are chosen randomly. Every individual has an equal chance of being selected and requires a list of every individual, which may be difficult or impossible to obtain. So this is good when you have a smaller population, such as all the students at our school. So for example, if we put all students at school in a hat. So all students' names are put in a hat. And let's say 50 are drawn And that's enough. So all students' names are put in a hat and 50 are drawn out of the hat. So that would give us a simple random sample. They call that a SRS for short, of 50 students. They were randomly chosen. Every member of our population had an equal chance of being chosen. A stratified random sample is when you divide the population into subgroups or strata based on a characteristic of the group members. Randomly select individuals from each group. So if we divide our school into grade levels, so divide the school by grade level, so freshmen, sophomores, juniors, seniors, those are strata, and then randomly select individuals from each group. So if we have freshmen, sophomores, juniors, and seniors, and then we randomly select 20 freshmen, 20 sophomores, 20 juniors, and 20 seniors, but still randomly selecting them. So let's say we put the freshmen in a hat and draw out 20. We put the sophomores in a hat and draw out 20. Same for juniors and same for seniors. So in each strata, you still need to make sure that each member of the freshman class had an equal chance to be chosen, and so on. So make sure, always keeping in mind that you're choosing a random sample. So let's say by grade level, we choose 20. So let's finish writing and choose 20 members of each grade level. And importantly, we have to do it randomly. Okay, a systematic random sample is when from a randomly selected starting point, you choose every nth individual. So say we're standing at the entrance to the school. We're going to continue to use our school as a good example. So standing at the entrance to the school, let's say we roll a die, so it's randomly selected, and we get a 6. So starting with the 6th student that comes into school, then we select every 6th student after that. That would gather us a systematic random sample. So standing at the entrance to the school, we roll a die and get a 6. So starting with the 6th student, we then select every 6th student, and you ask them a question or you put them into a group that you're going to do something with. So a cluster sample, the researcher divides the population into separate groups called clusters. Then a simple random sample of clusters is selected from the population. So this could be that with our classes, so our classes at school could be like our clusters, and we put those in a hat and we draw out, let's say 5 classes. So let's say classes are clusters, like Mr. Jones' class, Miss Green's class, Miss Hannon's class, those are our clusters. And then put all the classes in a hat or in a list and randomly generate a sample. So put all the classes in a hat or list and randomly choose 5. I need another O. Randomly choose 5 classes and select all students in those 5 classes. So notice there's a difference between stratified and cluster sample. People tend to get those mixed up. But a stratified sample is you divide them into groups, such as grade level, and you choose only some members from each grade level or group. Where a cluster sample means they're divided into groups like a cluster, but instead of choosing some members from the classes, you choose whole classes, but just a sample of classes. Okay, there's 2 more types we're just going to name off really quick. There's a convenience sample, which is mentioned often, And that is when you select individuals from a group that is conveniently accessible to the researcher, and usually there's a high likelihood this is going to be biased. For example, let's say I just want a quick random sample, but I just am in a hurry, so it's really not going to be random. And I just go next door and ask the class next door my survey question. So let's say I ask the class next door to take a survey. It's very convenient. I haven't really made sure I selected them randomly. You could also, for instance, like you want to find out something about people's TV watching habits, and you just go to the grocery store and you ask the first 20 people that you see. That's a convenient sample. You really have not worked to make sure you have a random sample of people that represents your entire population. So voluntary response sample is when you have individuals select themselves, so people decide whether to respond to the survey or not. The main problem with this method is that the people who respond typically have a very strong opinion one way or the other. It's like when they ask you on a radio station or a podcast or on TV to call in and voice your opinion. That is a voluntary response sample. You could also have a survey posted on a website, or they give you surveys when you've gone shopping and they're like, at the bottom of this receipt, there's a survey. Please call in or go online and fill out the survey. That's a voluntary response sample, and it usually brings forth people that have a strong opinion. And that's a certain type of people. They're extroverted typically. They want to call and talk out loud on TV or on a podcast. And that's not really representative of our entire population, because not everybody would feel so strongly. So let's put ask people to call in is a big one, or go online to fill out a survey. Those are two good examples of a voluntary response sample. So those are just two that you hear of often, and they are biased. So these are not good samples, but they are ones we just hear a lot in some of our questions. Okay, so that is it for our vocabulary for today.